heat catcher is an invention that captures exhaust heat from air conditioning units in order to lessen the intensity of the urban island effect in hot summer months. The urban heat island effect is a global phenomenon that occurs when the covering of natural land with buildings and cities results in the built-up area of land being much warmer than its natural surroundings. The urban heat island effect is caused by a range of factors, including denser populations, more buildings, fewer plants, and heat exhaust. In summer, heat exhaust from air conditioners adds heat to urban areas, which is then retained by man-made materials. The urban heat island effect makes our environment increasingly warmer and is a contributor to global warming and climate change. There are many implications of a warmer urban environment, such as increased power usage and pressure on power grids, less livable cities, increased mortality from heat-related illnesses, diminished learning outcomes for children, increased risks of fire and drought, and impacts on the economy. In this project, the contribution that different building materials have to the urban heat island effect was explored by testing their heat retention and cooling. The results showed that whilst all materials heat up when exposed to sunlight, they do so at different rates and retain heat for different lengths of time. The man-made materials tested took longer to cool after being heated than the natural materials. The results also showed that dark-colored materials reached higher temperatures and took longer to cool than light-colored materials. The heat catcher is an invention to help capture the wasted heat exhaust from air conditioners in the summer months, and then use that hot air on a purpose such as heating up water for domestic or commercial use. It would remove excess heat from urban environment by capturing it and would also help reduce the current energy usage to heat water. The heat catcher uses a heat exchanger to create a system which heats water using hot air. The heat catcher is designed as a unit that would fit onto an existing air conditioner to channel the hot air through the heat exchanger and allow the water to heat and flow through the pipes into a water tank. The first prototype of the heat catcher was constructed as a proof of concept and tested with a hairdryer, stimulating the air conditioner exhaust. The proof of concept prototype was successful in heating 4 liters of water to 58 degrees Celsius over a test period of 15 minutes. The efficiency of the system was calculated to be 38.08%. It was interesting to see that the system was able to heat water to a higher temperature than the air exhaust temperature, due to multiple cycles of water through the heat exchanger and the heat buildup in the pipes in the systems. From the proof of concept, the conclusion was that the system would work to use hot air from a source to sufficiently heat up water. A second prototype of the heat catcher was then constructed. This prototype was designed with a casing in order to improve the practical use of the unit to fit over an air conditioner unit fan, as well as increase the effectiveness by channeling the hot air to the heat exchanger. After construction, the final prototype of the heat catcher was tested. The heat catcher final prototype was more successful, as it heated 4 liters of water to an average of 62 degrees Celsius over the 15-minute test period. The test demonstrated that the casing of the heat exchanger improved the efficiency of the system, calculated as 42.42%, by channeling heat towards the heat exchanger unit and allowing less exhaust heat to escape into the air. In a further development of the heat catcher, improvements could be made to investigate efficiency, optimal shape and material of the unit casing, and designing different shaped units to be compatible with the different air conditioners in use. Through the design development, construction and scientific testing of the heat catcher prototype in this project, it has been demonstrated that the heat catcher could be a useful solution to help limit the impact that heated waste exhaust air has on the urban heat island effect.